There was a time on Earth when the largest predator didn't roar, didn't chase, didn't need to. It waited, hidden beneath dark water, completely still, and once it decided to move, it was already too late. Around 60 million years ago, not long after the extinction of the dinosaurs, the Earth was a very different place, not just slightly warmer, but fundamentally altered in ways that reshaped how life functioned, how ecosystems formed, and how large animals could become, especially those that depended on the environment for their survival. Deep in what is now northern Colombia, a vast rainforest stretched across the landscape, thick, humid, and endlessly warm, a place where temperatures remained high not just during the day, but throughout the night as well, with little variation, no real seasons, just a constant, heavy heat that pressed down on everything. This was not the kind of forest we know today. It was denser, wetter, more enclosed. Rivers moved slowly, clogged with sediment and organic matter, turning the water dark, almost opaque, while roots tangled beneath the surface, creating a maze of hiding places where visibility was limited and movement was controlled. And in this world, something enormous existed. In 2009, scientists working in a coal mine in this exact region began uncovering fossils from that ancient environment, preserved in layers of compressed vegetation and sediment, effectively creating a time capsule of a lost ecosystem. At first, the discovery seemed familiar. Large bones, heavy, thick, the kind of remains typically associated with crocodilians, which were known to dominate these types of environments. That assumption made sense, until it didn't. Because the bones didn't match, the shape was off, the curvature was wrong, and as more pieces were uncovered, a different picture began to form. These were not crocodile bones, they were vertebrae, snake vertebrae, but not from any snake that exists today. What they had discovered was Titanoboa, and the moment the measurements came in, everything changed, because this was not just a large snake, it was something beyond expectation. Estimates placed it at over 13 meters long, with some reaching closer to 15 meters, weighing more than a ton. A creature so large that it immediately forced scientists to rethink the limits of reptile size. But the real question wasn't just how big it was how it was possible. Because snakes are not like mammals. They are ectothermic, cold-blooded. They do not generate their own heat. Their entire biology depends on the temperature of their environment. And that creates a constraint, a hard limit. The colder the environment, the slower their metabolism. The slower their metabolism, the less energy they can process. And the less energy they can process, the smaller they must remain. So for a snake to reach Titanoboa's size, the environment had to be extreme, and it was. Temperatures in this region during the Paleocene are estimated to have averaged over 30 degrees Celsius year-round, with humidity levels so high that the air itself felt heavy, a constant greenhouse effect that trapped heat and prevented cooling. This kind of environment changes everything. Metabolism speeds up, growth accelerates, digestion becomes more efficient, and suddenly, the limits begin to shift. Titanoboa was not just surviving in this world, it was optimized for it. Its size was not an anomaly, it was the logical result of a system pushed to its extreme. But size alone does not make a predator successful. Function matters. And this is where Titanoboa becomes even more interesting. Because despite its massive size, it was not built for speed. On land, it would have struggled. Its body, stretched across dozens of meters, would have been difficult to lift, difficult to move efficiently, requiring enormous energy just to overcome gravity. But in water, everything changes. Water supports weight, reduces friction, allows smooth, controlled movement. And in the swampy rainforest of the Paleocene, water was everywhere. Slow-moving rivers, flooded forests, dark channels, shallow basins. This was not a place where speed mattered, it was a place where patience mattered. Titanoboa likely spent most of its time partially submerged, its body hidden beneath the surface, with only small portions exposed, blending into the environment so completely that it became nearly invisible. This was not camouflage in the traditional sense. It was environmental integration. It didn't need to hide. It simply became part of the water. And then it waited. For hours, possibly days, until something came close enough. And when it did, the attack was instantaneous, a rapid strike, followed by immediate constriction. Modern snakes kill by restricting blood flow, causing a rapid drop in blood pressure that leads to unconsciousness and death. But Titanoboa operated on a different scale. The force it could generate was immense, enough to crush bone, enough to collapse lungs instantly, enough to end resistance almost immediately. Its prey likely included large turtles, early crocodilian species, and massive fish, all abundant in its environment, all relatively slow-moving, all vulnerable to ambush. And once captured, escape was not an option. But here's something even more important. Water wasn't just where Titanoboa hunted, it was how it survived. At that size, its own body weight would have been a problem on land. Internal organs would be compressed, breathing would be difficult, movement inefficient. But water solved all of that. It supported the body, reduced stress, allowed it to function normally, and perhaps most importantly, helped regulate temperature. Because even in a hot environment, overheating is still a risk. Water provided balance, stability, control. But no environment stays the same forever, and that is where Titanoboa's story changes. After the Paleocene, global temperatures began to decline, not suddenly, but steadily, over millions of years. Rainforests shifted, swamps dried, seasonal variation increased, and the constant heat that Titanoboa depended on began to disappear. For a cold-blooded animal, this is critical, because even small temperature changes affect everything. Metabolism slows, digestion becomes inefficient, movement decreases, and for something as large as Titanoboa, that is devastating. It required enormous amounts of energy to survive. If it could not process food efficiently, if it could not hunt effectively, it would begin to fail. Not instantly, but gradually. At the same time, the ecosystem itself was changing. Mammals were evolving, becoming larger, more active, better adapted to fluctuating temperatures. They could function in cooler environments.
Reduced stress.
They could compete.
Allowed it to function
Titanoboa could
because
not
even in a
match that
hot
flexibility.
environment, overheating is still a risk.
Its entire existence depended on
Water
stability.
provided balance.
And that stability was gone.
Control.
Its prey declined, its environment shifted, and the system that supported it collapsed. Titanoboa did not go extinct because it was weak. It went extinct because it was too specialized, too perfectly adapted to a world that no longer existed. And that is what makes it so important, because it shows us something fundamental. The limits of life are not fixed. They are defined by conditions. Change the conditions, and the limits change. Under the right circumstances, something as extreme as Titanoboa becomes possible. Not just possible, inevitable. And then, when those conditions disappear, so does everything built around them. For millions of years, Titanoboa ruled its environment, unseen, unmatched, perfectly adapted to a world of heat, water, and silence. And then that world changed, and it vanished, leaving behind only fragments, bones, and a reminder that even the most powerful creatures are temporary. Because in the end, it's not about how strong something is. It's about whether the world still allows it to exist.